So after I have introduced the transformer architecture, I will show you how you can build a neural machine translation network using the transformer architecture in TensorFlow. First of all, we need to import transformer encoder and transformer decoder from Keras NLP module. And then the constants are defining here. The epoch is 20 and batch size 128. And don't forget to add the path for the data. If you are using Google Colab, you need to add this piece of code to have the access to the drive of the Google Colab, of Google Drive. Then we are reading the data, the training data, and tokenize the data. Similar to previous videos by using LSTM. The difference is here in the building the model. So this is the transformer architecture. As you can remember, I mentioned that we need to have the positional embedding because we don't have the recurrence layer in transformer. So this class is describing how we can calculate the position of the word using the sine and the cosine formula mentioned in the video. And here we are building the model. We can see the encoder model now consists of positional embedding and two transformer layers on top of each other. And we can print the summary of the model. We have an input layer, then positional embedding, transformer encoder, and transformer encoder 3. And then the decoder side, we have a positional encoding layer as well. Then we have two transformer decoder modules on top of each other. And then at the end, we have a fully connected softmax layer to predict the next word. This is the summary of the model. We can see that these decoder layers, they take as input not only the embedding layer output, but also it takes the output from the encoder. For example, where it can do cross attention on that. For example, let's see this decoder layer 2 output. It takes the output from the first decoder layer, and then it also has this decoder state input, which comes from the encoder. We can then put together the encoder and the decoder into a full model, an encoder-decoder model. Once we have that, we can go ahead and train this network. So we have for loop where we are calling the fit function, and then after each call, we will then loop through some samples to see the results of the translation. With transformer, we start with the start token, as you can see here, and do one iteration. That will predict the next word. And then we will concatenate these together. So we are appending, and as you can see here, we are appending the predicted word to the input sentence. And then we are going to next time around, and we'll provide it with the start token as well as the first word. And that's going to predict our sentence, second sentence word, and then append that. So now we have an input sentence of 3 words, and then we do that over and over. So we are basically predicting the full sequence each time around rather than doing it just one word at a time. Let's have a look at step 0. This is the sentence in Arabic, and I noticed that in the transformer architecture, the padding is taking care of how we start writing in the language. For example, in Arabic, we start from right to left. So this is the sentence in Arabic, لنذهب بالحافلة. And this is the sentence the true sentence, let's go by bus. And this is the predicted sentence. As we can see, it's not good. Are you? So this is the first epic. And I will wait until the training process will finish and to compare the results. Let's have a look at this sentence, for example, at step 4. The same sentence, لنذهب بالحافلة. And this is the true sentence in English. Let's go by bus. This is the predicted one. I don't know what you. So this is also not good. Let's have a look at step 6. It doesn't finish. So let's have a look at this sentence. لا تقلق حيالنا. In English, don't worry about us. The predicted one is I don't know. So still the predicted is not good. Let's see when the training process finishes how the output would be. The training has finished. Let's see. For example, the last sentence. This is in Arabic. لا تقلق حيالنا. This is the English. Don't worry about us. And the predicted sentence is don't worry about me. So still the model is not perfect, but is definitely better than the first step.